Hi, welcome to Learning Monkey. I am Raghu here. In this class, we'll discuss about homomorphism of groups. In our previous classes, we clearly discussed about groups and functions. Please watch those classes and come back here. The link for the playlist is provided in the description below. Coming to today's class, homomorphism of groups. Let's understand the definition, but with example, you are going to get good clarity. Let's take the definition. Let G star is a group and H delta be two groups. So this is one group and this is second group. What are these? G is the set of elements and star is the binary operation. H is the set of elements and delta is the binary operation. See here, two different operations. This is one group and second group. Be two groups. A mapping means a function f from G to H. So the function should be from G to H is said to be a homomorphic function, homomorphism. When we are going to say it as a homomorphism, that function f, if it satisfies this condition, what's that condition? If f of a star b, this is the binary operation in G, star is the binary operation in G, f of a star g equal to f of a delta f of b, delta is the binary operation from H. If this satisfies, for all the a comma b belongs to G, then we say it as this is a homomorphism. This is satisfying the homomorphism. So this is what the definition of homomorphism of groups. Now let's try to understand the example. The first example, G is a group that contains Z plus. We already discussed in our previous classes. Z plus is a group. It is satisfying the four conditions. What are those conditions? It has to satisfy identity element, inverse elements should be there, and it has to satisfy associative, and the first property is closure property. If all these satisfied, then we say it is a group. Yes, it is satisfying that. We are not explaining again what this group means. H is a group that contains set elements. Here set of elements is Z. Z means all the integer values from minus infinite to plus infinite. Okay, now if you take H is from 0, 1, 2. 0, 1, 2 means the set of elements that contains here is 0, 1, 2. And on this, you are taking the operation addition modulo 3. What's that operation means? Addition modulo 3. Here the binary operation is addition modulo 3. What's that operation? Take any two elements, 0, 1. If you take the two elements, 0 plus 1 modulus 3. That is what the binary operation says. Take two elements, 0, 2. 0 plus 2 modulus 3. That is what the binary operation is. Take two elements, 1, 2. 1 plus 2 modulus 3. So it is a group. It is satisfying all the four conditions. Now our definition homomorphism says f is a function from G to H. Take the values from G to H. F of x is equal to, and the function definition it was given that. So many of them are going to get confused here. F of x, this is the condition for function. Functions have some conditions from the basics of in our previous classes when we discussed about the functions. What this function says, f of x itself is saying that x modulus 3. Is this function f is a homomorphic function? Yes, it is homomorphism. It is satisfying the homomorphism. So we need to check that f of a plus b. Why we are applying plus here? Because in G we are having plus operator. What is the operation that goes here? Plus. This is equal to f of a plus addition modulo 3. Why we have applied this operation here? Because in H we are having addition modulo 3 operator. Addition modulo 3 f of b. So this is what we need to check. So f of a plus b means, what is the function of f? What is the condition for f? F of a plus b means a plus b modulus 3. So f of x is equal to x modulus 3. So this can be written as a plus b modulus 3. That is equal to f of a means a modulus 3. F of b means b modulus 3. In between these two, you have to apply addition modulo 3. That means this plus this whole modulus 3. This is what we need to check. If these two are equal for any a comma b that belongs to Z, then we say that this is satisfied. This condition, this is a homomorphism. Let's check for one of the example. Let's take a comma b as 5 comma 10. 5 plus 10 modulus 3 means 15 modulus 3 means 0. That is equal to a modulus 3 means 5 modulus 3 plus b modulus 3 means 10 modulus 3. 5 modulus 3 plus 10 modulus 5 modulus 3 means 2. 10 modulus 3 means 1. 2 plus 1 modulus 3 means 3 modulus 3, which is 0. So both are same. This is same for, you take any two values, a comma b, this is going to satisfy. So the function f from G to H is a homomorphic function. Homomorphism, it is satisfying homomorphism. So this is what you need to understand on group homomorphism. Hope you understand the homomorphism of groups. If you have any questions regarding the concept, please post your questions in the comment section below. Thanks for watching. If you haven't subscribed to our channel, please subscribe to our channel and press bell icon for the latest updates. Thank you.